Op amps. Op amps have two inputs, the inverting input and the non-inverting input. There's one output. They usually use what's called a dual rail power supply. So we've got plus 12 volts going in and minus 12 going in. Okay, instead of 0, it's minus 12. The output will range from around about minus 10 volts to around about plus 10 volts. The output can't get all the way to the supply. Okay, the output saturates at about 85% of the supply voltage. The input resistance, there's no current flows in here because there's a high input resistance. The same with the non-inverting input. No current flows in there because of the high input resistance. Okay. The simplest op amp configuration is the comparator. Now, so here we have set up the output. It's going through an LED to 0 volts. So when the output's high, the LED will go on. When the output's low, it won't go on. Two inputs. This one, for two resistors, we'll just make them the same size, 10k, 10k. That will be 6 volts. If we'll just divide that 12 volts in two, so that input there will be 6 volts. The other one, we've got an LDR on the top here. So the voltage here and then here will change as the light level changes. So in the dark, the LDR has a high resistance. So in the dark, high resistance, so the proportion of voltage here will also be large. So in the dark, that voltage will be large. This voltage here will be small in the dark. So that means that there is small in the dark. The non-inverting input will probably be bigger than that one. So in the dark, non-inverting input wins. So this goes high and the light comes on. So the LED will come on in the dark. In the light, the resistance of the LDR is small. So that voltage there will be small. The voltage here will be big. So in the light, that voltage is big, so that means the voltage here is big. The voltage at the inverting input is bigger than the non-inverting input. That one wins, so this will go low, so the LED won't light. The comparator. Useful for when you're wanting something to switch on and off.